Hi, it's Mike Stevenson here. In today's video, we're going to talk about a scenario we were looking at recently where we can discuss the differences between throttling and burst scaling and just look at a real world scenario where they came into play. So the example scenario here was we had messages being written onto a service bus queue. We then have function apps triggering from the queue, processing these messages, and effectively those function apps do a bunch of work and we end up with data in a SQL database. Now the error that was being logged was this request limit for the database 400 has been reached. And what we're going to look at in this video is just some discussions on how that error happens, what we can do to design around kind of making sure our solution doesn't get impacted by that. So first off, let's think about some of the constraints we've got in play here. So when we have an error like request limit reached, we know that's going to be some kind of throttling limit or some kind of constraint on one of the parts of the components in the application. So we know this error was really coming from the database. But let's think about what the constraints would be that affect this architecture. So I'm going to focus more on the kind of function app to SQL bit here, because we know we were getting messages coming in okay onto the queue, and we know service buses, there's very little kind of actual work involved there. Throughput's going to be really good. So if we think about the database and the function apps, so really on the database side, there's a couple of key things come into play here. So this varies a little bit depending on what kind of database and what configuration you've got, but really, a good example here would be 2 vCores. We've got this maximum concurrent workers of approximately 600. We might scale that up to a 4 vCore database and we get more workers. I can't remember off the top of my head the exact database setup it was. I think it might have been a D2U based one that might have had a slightly lower limit. But this is one of the key parameters that comes into play in this architecture as to how many concurrent requests can that database kick in or can that handle. So if you take this specific bit here, we know that that was a limit on the database side. Now we do have to factor in things going on in the function app, because an easy way to, or a common way people would tackle a problem like this is they'll just go, well, we just go to the database, we just scale it up, and then we make the problem go away. But actually, in reality, if you tackle the problem like that, you're going to do a couple of things. So number one, you might miss the underlying root cause issue, and you're going to spend a lot of extra money and just keep throwing money at the problem where there might be other things going on. So you need to think of the bigger picture for troubleshooting a problem like this. So the first thing we might think about in constraints on the function app is going to be the SQL connection pool. So each connection string we're using in the function app by default is going to have a pool size of 100, but we can configure that to be bigger or smaller. So that means each function app can make up to 100 concurrent connections that it can then use and execute requests on. Now, it may also be executing multiple different kinds of requests depending on what's going on inside your function app. And then the other configuration that really comes into play here. So this section's from the host.json. So we've got some configuration for Service Bus, and kind of the two key bits that come into play are the prefetch count and the maximum concurrent call. So this is how many messages we're going to process concurrently, and when we reach out to Service Bus, how many messages are we going to load into memory to start working through. So this is going to affect, for each instance of the function app, how aggressively it's going to be processing messages. Now, I think in this case, if you imagine the simplest scenario, if we had a moderate size number of messages, we just have one instance of the function app, we probably wouldn't get anywhere near these throttling limits at all. But we've got to remember that on function apps, we can scale these out quite dramatically under load scenarios. And I think in the case of this scenario, we also had the additional complexity that there was a bit of a problem with the implementation for processing one of the message types. So what was happening is this message was taking a lot longer to kind of get processed. So then when you have these connections, you're not like really quick where you're just using them, do your work and move on. They were being held around for a lot longer because of a lot of database activity going on. So if we go back to the diagram for a second, so what was really happening is we've got a lot of messages coming in, and then the function app just starts scaling out because the way the trigger would work, it knows that it can just start getting more nodes from the apps, or from the function app's hosting infrastructure, and we'll have all these messages being processed concurrently to be able to interact with that database. So if you imagine in the case where we've got the settings there, we've got 16 messages processed at once for like one instance of the function app, and we're just scaling out. And eventually, if we allow the plan to scale out far enough, we're eventually going to hit the limit on the database side where we'll have a problem. So what we could do in this architecture, you've probably got App Insights available, and you can see here an example where we can see all of these nodes under the hood starting to spin out on function apps, and we could see each one of them's got potentially 100 connections to the database being used. Each one of them's processing a bunch of messages that may be bigger or smaller depending on your host.json. So you can see how all these different parameters start coming in to affect the behavior of what's going on. Now, at the point I took this screenshot, you can see there's not many messages being processed, so it was starting to calm back down. But at the point where we had the issue really kicking in, there's a lot more messaging going on each of these nodes, and it just scaled out. And if I remember off the top of my head, I think it scaled out to about 40 nodes where it starts kicking that limit in. So within App Insights, there's a couple of things we can do to look for this message. So the easy one was we just looked in the traces for anything with that error message. You'd get an error message like that, and we can start digging into the logs if we need to learn a bit more about what's going on. Now, for me, there's a couple of things here. So there's like a short-term remediation and a longer-term fix the root cause. So the first thing you're going to have to do is sort of what can we do to get things into a manageable state for the short term, while we might have to fix some coding issues that would then longer term make this less of an issue. So there's a couple of things you can do depending on how you've configured your function app that for me in this scenario, we could really just control the scale out and leverage the throttling that we've got via the service bus. So, I guess option one's just throw money at it and scale up the database, but that doesn't always fix the problem, and you're spending a lot of money. So the other option is throttle the function app processing and use the load leveling on service bus. There's a couple of ways we could do that. So if you're on an Elastic Premium plan, then you can go to the plan itself. You go to the scale out, and you'll see you've got these settings here. So the burst settings and the minimum settings. So, but I think if I'm right, by default it has about 20 nodes. By default, you can then drop that down to one. You can go as far down as one node for the maximum burst out, depending on kind of what you're doing. So that's one option on Elastic Premium. You can configure the entire plan to control the scale out. The second option, if you're on the app itself, so if you imagine my Elastic Premium plan might have multiple apps doing different jobs on it, so you might say we want to control how far one app scales out, but the others were fine to let them do whatever they like. So what you might do on the function app itself rather than the plan, you can go to this scale out section, This bit up here is really about the plan, so it's the same as what we were looking at on the previous slide, but here on the app itself we can control scale out of the app. So you could use this bit here, and you might dial this down and kind of make it so it only scales out so far for this one app. So that's quite nice, couple of good options there on Elastic Premium. And then if you're on a consumption plan, you can do a similar thing here where we can go to the scale out tab, and then we can control the application scale out, turn it on, and we can set a limit of how many instances of the app can run at any one time. Now, that would mitigate the risk short term, so we calm the processing down to kind of keep within the constraints. So we took the approach of reduced concurrency. Now, there's other things you might do. So one of the things is you might control the .NET code on the function. You might control the SQL connection pool to make it bigger or smaller, and that would then let you be processing the functions. But if there's not as many connections in the pool, you'll just wait till one becomes available. And you can do, you could even bring in like retry logic if you need to. So that's kind of moving the problem away from the database up into the function code itself is kind of what you're doing there. Now, probably the most likely root causes for this are probably the middle two. So you might be able to optimize some queries. So if you've got long running queries, they're always a big red flag if you've got this kind of problem. So if you're starting to see throughputs affected, anytime you've got lots of long running queries, it's kind of like putting a funnel on the number of requests. So these are going to hog connections for a long period of time. So you need to get rid of as much of that as possible. Another common one would be things like ORM frameworks are often quite chatty. So the more you can move, certainly from a request perspective, the more you can move stuff to be done as work in the database with maybe something like a stored procedure, the less you've got going on in an ORM framework. There'll be less chatty backwards and forwards to the database, which will probably improve your throughput quite a bit. And then I think for me, what you should be doing is kind of working this way to mitigate. And I think what a lot of times happens is people just jump straight to this option and kind of don't really give a chance to see what you can do in these other options up here. So I would say, last option would be scale the database, but at least let's rule out there's no low-hanging fruit in the other areas first. And if you have got through all theirs and there's nothing you can do and you just need to scale the database, that's fine. But that has a cost trade-off, and you might be just hiding the problem that you've got elsewhere that'll just come and bite you. And I've seen in the past where projects just keep scaling and scaling, and then suddenly they're spending an absolute fortune, and you could have fixed a couple of queries and never had to scale in the first place. That's what you want to avoid happening. So hopefully this video was just some thinking about how to tackle these kind of problems, talking about some of this throttling versus scaling scenario. Thank you for listening, and we hope you have a great week.